Hey, what's up? In this video I'll be going over my drone build. It won't be a full how to build a drone video, but I will outline some of the steps I went through. So the first thing I did was some light research on drones. I then found some components that fit the bill and ordered them online. To go through the list, you have the drone frame, which is pretty self-explanatory. The only thing worth noting is the power distribution board that comes on the base, which is basically used to connect all your ESCs in parallel with your battery. As you can see here, I have a male XT60 connector for my battery and some 3.5mm bullet connectors to power my ESCs. I also have this 2-pin servo lead, which I'll connect to a battery meter later, and this male JST connector, which I'll explain later. You then have the optional landing gear or legs, 4 ESCs, 4 brushless outrunner motors, and 4 propellers. Now it's important to note that for a basic X drone like this, you want 2 motors that rotate clockwise and 2 that rotate counterclockwise. And generally speaking, you want the front left and back right going clockwise, and the front right and back left going counterclockwise to balance the drone. For the clockwise motors, you also want clockwise rotating propellers, which means the leading edge is facing clockwise, and you want a prop nut that locks by rotating counterclockwise, or in other words, a reverse thread. This allows for self-locking, which basically means the nut tightens or stays locked as the propeller rotates. For the counterclockwise motors, it's the exact opposite. You want counterclockwise rotating propellers, meaning the leading edge is facing counterclockwise, and you want a prop nut that locks by rotating clockwise, or in other words, a standard thread. If you take a closer look at the propellers, typically you'll also be able to see some markings that describe the propeller. For instance, here it says 1045R, which means the propeller is 10 inches wide with a 45-degree angle of pitch, designed to be rotated in the right direction. Alternatively, it may say 1045L, which means the propeller is designed to be rotated in the left direction. You'll also notice a lock and unlock image, which gives instructions for the prop nut. And if all this is unclear, a general rule of thumb is to have the side of the propeller with the markings facing upwards. Most propellers also come with a set of prop spacers, which allows the propeller to fit multiple motor shaft diameters. In terms of selecting a propeller, motor, and ESCs, you should look for how much thrust your propellers are able to supply under what conditions, and then match the motor and ESCs to provide the conditions that will lift the weight of the drone. Next, you have the flight controller, the battery, the receiver, and the transmitter. Now, each of these things I'll explain in more detail, but basically the transmitter sends a signal to the receiver tells the flight controller what to do, and the flight controller handles the events accordingly. And the battery simply just powers the drone. It is worth noting that when you're selecting these parts, you should make sure everything can communicate with each other first, which might take a few minutes of research up front, but can save you a lot of trouble down the line. So the transmitter I'm using is the FrSky Taranis X9D Plus, which isn't the cheapest controller out there, but it had some good reviews, and I found it to be quite user-friendly. You have the 2 thumbsticks, the on-off switch, the trims, the switches and knobs, and the menu panel. Now, to keep the video short, I'm going to skip a lot of the finer details, but the instruction manual for this is quite clear, and it's one of those things that might seem daunting if you haven't built a drone yet, but once you build or try to build one, the world opens up. So when you turn on the transmitter, you get this page, which shows some basic information like switch position and trim. You can then flick through the pages by clicking the page button. There's not too much on this page set, but if you click the menu button, you get a whole new set of pages. As you can see in the top right corner, there are 12 pages, but because I was only looking to get a simple flight going as quickly as possible, I put my focus in the bare minimum. For instance, on page 2, the only things I really changed were the model name and the internal RF mode from D16 to D8 to match my 8-channel receiver. I left page 3, 4, and 5 as default. On page 6, however, you have the mixer, which is where you link your switches and knobs to the channels. As you can see, the first 4 channels are linked to the thumbsticks for the throttle, aileron, elevator, and rudder. However, I've also linked the 3-position switch E to channel 5, which I'll use to change the flight modes, and I've linked the 3-position switch D to channel 6, which I'll use for arming the drone and setting off the buzzer. To link a switch to a channel, all you have to do is hold down Enter to open the pop-up, then press Enter again to go to the edit page. Once you get there, all you need to do is go to the source option, press Enter, and toggle the switch you want to link up. Press Enter again to set your change, and exit to return back to the main menu. Page 7 to 12, I also left as default. Just remember you can always come back and make modifications if required. And that's pretty much it for the transmitter. I've purposely left out binding, which I will explain after I go over the receiver and flight controller. So the receiver I'm using is the FrSky D4R2. It has 4 channels by default, but you can get 8 channels out of it by connecting channel 3 and 4 using a jumper, after which the 8 channels are transmitted via CPPM through channel 1. Next we have the flight controller. I'm using a NAS 32 revision 6 with 10 degrees of freedom, which is kind of old at this point, but yeah. The main pins I'm using on the ESC port are 1 to 4. Now if you don't plan on customizing the pin outputs, the default should be to connect the Servo 1 pins to the back right motor, Servo 2 pins to the front right motor, Servo 3 pins to the back left motor, and Servo 4 pins to the front left motor. It's also worth noting that you only need to power the positive voltage rail once, and therefore only need the 5 volt signal from one of the ESC-BSC connectors, and in my case I've taken the 5 volt signal from ESC1. The main pins I'm using on the input port are ground, 5 volts, and pin 1 for the CPPM input from the receiver. And the main pins I'm using on the auxiliary port are the VBAT pins for the battery meter and the buzzer pins, which I've connected to a 5 volt passive buzzer. At this point you can power the flight controller and receiver and bind your transmitter to the receiver. To do this, go back to the transmitter and click the bind option. It will make a beeping sound to let you know it's trying to bind. Next, power up your D4R2 in bind mode, i.e. by holding down the FS or failsafe button as you turn it on. If the receiver isn't bound yet, the LED should flash red. Once it's bound, you'll see a green LED plus a blinking red LED. Note that it may take a few goes to bind, but once you get it, simply power off the receiver and transmitter and switch them both back on. You should see a dimly lit green LED on the receiver. Now that's pretty much it for your basic flight controller, which brings us to the video transmitter, the camera, and the video receiver. For the camera, I'm using a RunCam Swift 2. For the video transmitter, I'm using a 600 milliwatt 5.8 GHz ImmersionRC transmitter. And for the video receiver, I'm using a 5.8 GHz receiver from eBay. To connect everything is pretty straightforward. Simply connect the 5-pin and 2-pin Molex SL wires that come with the transmitter to the video transmitter. Connect a 1.25mm Pico 5-pin connector to the camera, then solder the corresponding wires together. Note in this particular case, you don't need to connect the VBAT pin on the camera to any other. Now, to power the video transmitter and camera, you simply need to connect the remaining 2-pin wire to a voltage supply. And while you could connect it straight to the battery, a better method is to connect the battery to the input of an LC power filter and connect the output of the power filter to the 2-pin wire. And that will help clean the signal for a better picture. If you remember earlier, there was an unexplained 2-pin JST wire attached to the power distribution board. And essentially, this is what that's for. Just make sure the antenna is attached before you turn it on, otherwise you can damage your circuitry. And FYI, I'm using an LC common mode filter with a max voltage rating of 16 volts and a max current rating of 1.5 amps. For the video receiver, connect one end of the micro USB to the receiver and the other end to your phone. Note that the order does matter, so if it doesn't work, try switching the connector positions. Again, make sure the antenna is attached before turning it on to prevent damaging the circuitry. Now, there are a number of apps out there that this can work with, and it's up to preference on what you like, but once you get everything connected, simply hold down the button for an auto scan of frequencies, and if it finds a match, it should display on your phone. So now that we've gone over most of the hardware, we can switch our focus to the software, or the programming of the flight controller. For this, you'll need to get a flight control configuration tool and in this case I'm using the Betaflight Google Chrome plugin. Once you've got that, opening it should get you this page, and the first thing you'll need to do is download the correct driver, which in my case was the CP210X, but if you're not sure you can download both. Then you can connect the NAS32 to the computer via a micro USB cable. Now if you run into an error or warning that says non-clean flight Betaflight firmware is not supported except for CLI mode, it means you need to flash the firmware on your flight controller. To do this, unplug the NAS32 from your computer, short the bootloader pins together, and plug the NAS32 back into the computer. It may take a few times for this to work, but once it does, you'll know when it's worked because the blue LED will be the only one lit. If you also see a flashing red LED, which is the status LED, it means it's failed to enter bootloader mode and you need to restart the process. Once you've entered the bootloader mode, go back to Betaflight and click the Flash Firmware tab. Select the correct board, in this case it's the NAS, and the latest stable firmware. Then there are a number of combinations you can try to get the firmware to flash, but the most effective I've seen seems to be with no reboot sequence, full chip erase, and the manual baud rate options checked. Next, click the Load Firmware Online button, followed by Flash Firmware. Now if the flash fails and returns no response from the bootloader, it means you need to disconnect the flight controller and redo the process. If the flash fails and returns timed out programming failed, you shouldn't need to disconnect the flight controller and should be fine with just re-clicking the Flash Firmware button. It may take a few goes to get this. Once that's done, select the correct USB port and click Connect. You should get this page here with menu tabs on the left and some indicators at the top. As you can see, I have the gyro and accelerometer on, and you can turn them on or off by clicking them. Some options may not be toggled, however, if your flight controller doesn't support them. If you don't see all the tabs on the left, simply enable expert mode. And if you still don't see all the tabs, it may just be that your flight controller doesn't support that particular option. For this particular setup tab, it obviously shows your drone's orientation, which is useful to make sure everything is pointing in the right direction. And the only thing I needed to do for my build was calibrate the accelerometer, which is done by putting the drone on level ground and clicking Calibrate Accelerometer. And what this does is basically teaches your drone what level is. Next you have the Ports tab for if you have extra peripherals, which I don't, so I left these as default. In the Configuration tab, there's a few things to go over. In the Mixer section for a basic Quad X, you'll want to select the Quad X option. And in the ESC Motor Features section, I use the basic PWM protocol. The board and sensor alignment section is where you can reorient your flight controller. So on your flight controller, there should be some indication of which way is front by default, but this doesn't mean you have to have it facing the front of the drone. And if you don't have it facing the front, the board and sensor alignment section is where you would make the correct transformations. For the receiver, I'm using ppm, and I have my battery limit set in the battery voltage section. In the failsafe tab, I simply have it so the drone will drop out of the sky should the signal be lost. The PID tuning tab is for manipulating the PID control formula, and you can change the values as required, but I left these as default. In the receiver tab, you can see your channel signals, and if everything is connected, you should be able to see the changes. Now for the Mode 2 Taranis X9D Plus, where the throttle is on the left, the channel mapping you want is TAER1234. You can also set the deadband values to cater for any signal noise. In the Modes tab is where you link features to your auxiliary channels, and as the bare minimum, it's usually good to set arming, angle, horizon, and a beeper. So arming is basically a master switch for the motors, and the way you set it is by selecting your chosen auxiliary channel. You should then see a yellow tick, which indicates the signal received from the channel. When this tick is within the set slider range, the feature is on, and when it's outside of the range, it's off. So if I flip the switch now, the drone should be armed, and I can control the motors. If I flip the switch again, the drone should be disarmed, and all the motor controls will not activate the motors. Angle is for self-leveling, where you can't do flips and rolls. Horizon is for self-leveling, where you can do flips and rolls when the stick is at full deflection. and acro, which isn't shown here but is set by default if angle and horizon aren't selected, doesn't auto level the drone and requires manual control. And beeper is self-explanatory. The adjustments tab gives you settings for if you want to be able to set your PID variables out on the field, but I left all these as default. The servo is where you can set up servos, but for a multi-rotor you generally don't need them, so I left all these as default. In the motors tab you can test your motors, making sure they're spinning in the right direction by clicking the enable motor control toggle and moving the respective sliders. One other thing you can do is use the master control to set the throttle range for your ESCs. In the sensors tab you get a visual of the received sensor signals, which is mainly used for testing. The tethered logging tab is, I guess, a way to log data, but I basically just ignored this tab. The black box tab is again another way to log data, but obviously my flight controller doesn't support this. And last but not least, you have the command line interface tab. Now, a lot of things obviously have a graphical interface which makes things easy to use, but not everything does, and for those things that don't, you have the CLI. And that's pretty much it for your basic drone. Obviously there's some things I skipped over that I didn't think were necessary for my build, and I would definitely recommend going over everything individually, but hopefully that should be enough to get you at least playing with the drone. And yeah, thanks for watching.